Hi everyone. We know how to use ggplot to build thematic maps like choropleth maps, dot maps, density maps, and base maps. But how can we read external data from other GIS softwares to build more thematic maps? Or how can we store and share data with my colleagues? Today we are going to learn how to read and write shapefiles and dive into the components of an SF object. So, as usual, you can pause this part of the video to read through the learning objectives of the lesson of today. We're going to start with shapefiles. It is the most common format for storing spatial data. How can we read shapefiles? We can use the read_sf function from the SF package, from local files with an shp extension. And the results is a ready-to-use SF object. So, as an example, we're going to read one of these files. First, we need to identify the file path of the file. For example, this file is located within the chapter folder, within the data folder, and within the boundaries folder. So we need to specify the whole path to this file. And the second step is to paste that path into the read_sf function within the here function. So, for example, here we can fill in the blanks with the read_sf function. We need to use the here package because it allows to identify the file within the context of an R project within RStudio. The output is an SF object, and we can use this object to create a map using the geometries function. So we can check that out with this with the class function, and also we can start to make a ggplot statement to check the object that is within this file. Now it's time to practice. Now it's your turn to read the shapefile that is stated in the instructions of this practice question and use the read_sf functions to complete this task. Go ahead. Okay, so wait, shapefiles do not come alone. These shapefiles came with a list of subcomponent files. For this, let's check the data boundaries folder. With this piece of code, we're able to get access into the elements that are within the folder that contains our shapefiles. And we can identify that we have 4 files with different extensions. We need to understand what is the relationship between these files and the final SF object that we got when we read the file. So to have a complete understanding of shapefiles, we need to understand SF objects. So let's look at their components. As a quick reminder, SF stands for a simple feature, which is a well-known standard to sort geometric shapes. So now, what SF objects look like? We're going to see an example with the countries object. So for this, we're going to get access to country data. We need to remember that SF is a special kind of data frame. This means that we can manipulate their content with diverse functions. Let's select 3 columns. Okay, we just run the select function to the countries object to select the name, the population estimate, and the geometry column. But this output have a lot of components. First, we can identify a 5-line header. that goes from simple feature collection to the line called CRS. And then it comes a data frame that goes from the content that is below the first 10 features. Here we have 9 rows and 3 columns. The header provides context about the rest of the object. So the most relevant sections are first the features and fields. This section tells us the number of features and fields available in the SF objects, and it is highlighted in the first line of the header. So features refer to the rows of the data frame. So in this case, this shapefile have a total amount of 177 rows. And in this data frame, each country is a feature and also a row of the data frame, while the field refers to the attributes of each feature or also to the columns of the data frame. However, we need to know that the amount of fields is equivalent to the columns, but not counting the geometry column. In this figure, we can see that we have 4 features, but we only have 2 fields because in the counting of fields, we do not take into account the geometry column. Now it's moment to practice. For practice, let's look at the NC object of the SP data package to count the number of features and fields that are available in this object. Take your time to solve this question. Okay, so now let's talk about geometries. So this section gives you the type of geometry that is available in the SF object. It is highlighted in the second row of the SF header. In this case, the geometry type of this shapefile is multi-polygon. As a reminder, geometry is a synonym of shape. These geometries are of 3 main types: point, lines, and polygons, each of them with their multi-versions. As a summary, we can recall to the graph that contains the relationship between the geometries and the type of thematic maps that are related with each of them. So now let's practice this concept. Use the NE download function from the Air Natural Earth package to obtain the map of the major world roads. And with that data, answer the following question: what type of geometry is used to represent the rivers? Please take your time to solve this question. Now, let's look to the side note. Each individual SF object can only contain one geometry type. So this means that you can only have points or only lines or only polygons in your SF objects. You will not find a mixture of geometries in a single SF file. And one interesting feature is that the geometry specification in the second line of the header is related with the geometry column available in the SF data frame. This geometry column is the most special property of SF objects. The reason is that it holds the core geospatial data. For example, in the line of the header, it stated that the geometry type was multi-polygons, and their corresponding column in the SF data frame is below the geometry column, where each of the rows have a multi-polygon that correspond to the geometry type stated in the header of the SF file. Now, some interesting points about this column. The first one is that geometry can be dropped. And if we recall, when we try to select only 2 columns from the shapefile, the geometry column appeared. And the second interesting point is that And the second interesting point is that the geom_sf function automatically recognizes the geometry column. For that reason, we do not need to specify the geometry column when we use the geom_sf function. Okay, now let's see a third component of the SF header. We have seen the features and fields, the geometry, and now we're going to see the CRS. The CRS tells us about the coordinate reference system used for this shapefile. It is highlighted in the last line of the header of the shapefile. The CRS relates the spatial elements of the data with the surface of the Earth. For example, some of the components of the CRS are the coordinate system that is used, like the longitude and the latitude, and also the map projection, which refers to which type of geometry we are projecting the world into a cylinder, into a cone, or into a different geometry. Until now, we only need to know that CRS are a key component of geographic objects. And don't worry, we will cover it in detail in the following lessons. So, getting back to the shapefiles. Now that we know the components of an SF object, let's relate each of them with the components of the shapefile. So, shapefiles are a collection of files, at least 3 files, and each of them are related with components of SF objects. In this figure, we can see that the .shp file relates with the geometries of the SF object. The .shx is an index file that allows to relate the geometries with the data frame that contains the attributes of all the rows of the data frame, and related with the .dbf file available in the shapefile folder. So let's see the components of this shapefile. All the components are located within the same folder, the boundaries folder, within the data folder. So again, to check all the components, we identify that we have the .dbf file, the .shp file, and the .shx file. The .shx file is the one that connects the shp file that contains the geometries and the dbf file that contains the attribute for all the rows. So what is inside of each of these files? As we recall, the shp contains the geometry, the dbf the attributes or field of the SF object, and the shx is an index that link these two other elements. But what about this other element that have the extension PRJ? It describes the coordinate reference system, including the map projection. So from projections, you have the extension name. All these files need to be compressed into one zip folder to be shared. So now, an important message. All the subcomponent files must be present in one same directory, and only then that shapefile is readable. For this, let's put this task into practice. Let's see which of the following options of component file of shapefiles contains the geometry data and which one contains the attribute of for each shape. Now that we have related SF objects and shapefiles, how can we write shapefiles? For this, let's use the countries object and try to store it into a countries.shp file. First step is to define the file path of this new shapefile. And we have decided to locate this file into the new shapefile folder. And within this folder is going to be the countries.shp file. And then instead of using the read SF file, now we use the write SF file within the here function as well. So we now need to write SF, use the here function, and locate the path within this function. Okay, so now all the components of the SF object are located in new files of this shapefile. So we can review this looking at the components within this folder, and now we see that we have 4 files: a .dbf file, the prj, the shp, and the shx. The data frame, the geometries, the index that associate these objects, and the projections that contain the coordinate reference system. Okay, so now it's time to wrap up. In this lesson, we learned how to read and write shapefiles using the SF package. And we identified components of SF objects and relate each of them with the components of a shapefile. And yes, SF is a package that allows us to simplify spatial data in a lot of ways. Now, we need to solve this CRS question. So in the next lesson, we're going to dive into the CRS element. So hopefully now you feel more comfortable with SF objects and shapefiles. See you then in the next lesson.
For more resources, visit our website, where you can track your progress, access interactive quizzes and lesson notes, and connect with our teachers and other learners like you. And if you'd like a more guided experience, we also offer live online bootcamps with expert help. So join us at thegraphcourses.org to start your learning journey today.